Uh, what we have here is question 4. Now, question 4, you're asked to get angle A. If you're asked to get an angle, how does the question have to end? Inverse of some variety. If you don't do the inverse of some variety, it means that you haven't you're not doing an angle question, you're doing a length question. Okay, that's very important that you establish that straight from the start. Next thing is, I know, let's do the sine rule. Try the sine rule first, and you say, look, sine A over, yeah, we'll do it that way. We'll do 4 over sine A, yeah? And then you pick one of the other sides, and you say, oh, look, 6 over, and then you're like, I haven't got enough information, do I? Something's up with the sine rule, I can't do it. If I was to call that sine B, I have 2 letters and 1 equation. Can't be done, not able to do it. So the way I'm trying to teach you is that you don't have to learn off what rule for what. You try one way, you end up with 2 letters, and you're like, I can't do this, I need to choose a different path. Okay? So what you then do is, some of you might think, oh look, 3 sides, SOHCAHTOA. Why not? Not a right angle triangle. Your second option is gone. Pythagoras' theorem will only give you a length, and you already know all 3 lengths. So Pythagoras' theorem only ever gives you lengths, and you know all 3 lengths. We're not doing the sine rule. We're not doing Pythagoras' theorem. We're not doing SOHCAHTOA because it's not right angled. That leaves us the cosine rule. A squared equals b squared plus c squared minus 2bc cos A. Now, what I ask you guys to remember is this. See this 2bc cos A business here? That is linked together by multiplication. Multiplication's like glue. Alright? You can only undo multiplication by division, okay, or cross multiplication. That part there is stuck together like glue, and you got to take that apart separately, okay? So what happens is this. You choose A. A is the angle you're looking to use. That A, you choose that to be A. If that said X, you'd say the angle is X. You then choose the side that is opposite it. What side is opposite capital A? What side is opposite capital A? 4. That means that's got to be small a. They're the first 2 parts you fill out. All other parts are interchangeable. So the 6 and the 5. 6 squared plus 5 squared minus 2 times 5 times 6 cos A. Alright, I already had an A there. Now, capital A. Now, the biggest mistake kicks in here, guys. 16, 36, 25, 2 times 5, 10, minus 60 cos A. What people do every year, and honours level, pass level, you name it, they all do this. They put the 3 of them together. Why? Why can't I do that? BEMDAS, thank you. BEMDAS. BIMDAS. What Lee's saying is that the order is that multiplication and division occur before addition and subtraction. Before that 60 becomes active, it needs to be multiplied by cos A, or in simpler terms, it's bound to the cos A by multiplication. Therefore, it's not in a position to be added to the 36 and the 25. Is that okay? So, what? So the 36 and the 25 are separate, okay? We bring the 36 and the 25 over the other side, or we could join them together as 61 and bring the 61 over the other side. So 16 take away 61 minus 45. Okay, it's alright. And then that equals minus 60 cos A. Angle questions always end this way. This box here stays the same to the very end. Multiply both sides by minus, and I'll turn it around at the same time. 60 cos A equals 45. Divided by 60. 45, get the cos A on its own first. It's going to be 45 over 60. Okay, then after that, how do I get A on its own? Cos inverse 45 over 60. If you brought the 60 up, you're only getting 45 on its own. You want to get A on its own. To separate A from cos, the only way to do that is by cos inverse. Yes? In traditional maths, Liam, cos A equals 45 over 60. If you did cross multiplication, the cos would technically appear underneath there. Is that what you're telling me? Cos A, sin A, tan A, alright? There are exceptions to this rule. The only way you can separate cos from A and sine from A is using cos inverse, tan inverse, and sine inverse. Only for those three. Otherwise, you'd be correct. So this here, you're not allowed to do. To separate cos from A, you have to use cos inverse. Is that right? Okay. So what's cos inverse 45 over 60? Anybody? 41.41. Okay. Good. It does at the start. We know how to get the answer, and just tailor it to whatever specifications the question asks you for. Nearest degree, nearest 1 decimal place, 2 decimal places. Trust you can take care of it. Okay, these questions are similar. No worries there. This one here, however, calculate the greatest angle. Which one's the greatest angle? B. You could write it two ways. You could call it the angle BAC. You could call it the angle CAB. Sorry? You can call it angle A. You could label it with your own. You could label it with your own letter and call it angle X if you want. You could label a lowercase a. No, don't, not with lowercase a, because lowercase a is technically the length that's opposite angle A. So don't use lowercase a. All right. Now we're almost making it too technical. Okay. Now you write down the cosine rule, the generic cosine rule. Now what I'm asking you guys is don't use the letters. Okay. As in, you write down this. Don't even think about what that means for a minute. Don't even think about it. I don't. Right? Here's the only thing I think about. What is the question asking me for? Is it asking me for an angle or a side? An angle. What angle is it asking me for? This is also, and I've called it X. This is all I see. I'm asked for that. The position of the angle in the equation is that. Okay? The next thing I look for is what's opposite the angle I'm looking for. That automatically makes that one the 9. And that's the only two parts of the full thing I look at. Everything else just falls into place after that. So what I look at is this. That's 9 squared. And then I go all the way down the end and I call that cos X. Okay. Next thing I look at is what is B and C. It doesn't matter which way you do it. 4 and 7, 7 and 4. It doesn't matter. Okay. The only parts that matter are the highlighted parts. Okay. And then 7 and 4. Okay. Once again, to prevent myself making that classic mistake, what do? I just box this off. I'm basically saying it's not accessible to the rest of the equation because I need to get the rest of the equation on its own on the left hand side. Okay. Because of BEMDAS or BIMDAS, it's not accessible. Okay, so it's 81 equals 49 plus 16, and then that's 2 times 7, which is 14. 14 times 4 is 56 cos X. I merged the two of them together to become 65. It's then going to transfer over to the other side to become 81 minus 65, which is 16. 16 equals minus 56 cos X. Okay, prediction. Can anybody make a rough prediction on the size of this angle? Just roughly its size. Bigger than 90, smaller than 90? Over 90 anyway, and probably more likely over 100. Why is that? Is that the only angle that is allowed to be over 90 degrees? Why? It's the biggest angle in the triangle, and it's the only one that's allowed to be over 100 degrees. If you did the cosine rule for the other two, they have to be smaller than 90. What you're doing there is exhibiting control over your question. You're making a prediction on what you're expecting. If that prediction doesn't come true, you've made an error somewhere. So that's looking for the error. You're starting to look for the error before the question is even done. Yes? No. You have to make that call yourself. Is it right angled? No. SOHCAHTOA, Pythagoras can't use it. When I use the sine rule, do I have enough information to use it, or is there two letters in one equation? Two letters in one equation, can't use sine rule, use cosine rule. Yes? Yeah, in a second, yeah. So, good question is, why don't I divide the x and 16 under x is what you're telling me? That's a very logical question, thought process, right? Remember I was saying sine, cosine, tan are special. As in we can't separate, we have to separate them using sine inverse, cos inverse and tan inverse. You can't think of cos and x as a separate, two separate parts. You're going to treat them as one separate part, glued together. You can only move them both together. So cos and its angle are glued together to the very end. The only way they can be separated is by cos inverse, sine inverse, or tan inverse. Is that okay? Now, bring the minus 56 underneath, or actually, to be honest, we'll multiply both sides by minus 1 first, and then we'll bring the 56 underneath, and we'll get cos x equals minus 16 over 56. The prediction is, if this is below 90, we're wrong. If it's above 90, more than likely we're right. Okay? So cos inverse minus 16 over 56. It's okay? Yeah. Thank you. 106.6, and you get 107. Okay? It's grand. Now, I won't